This is the story of aspirin. John Byrne presents the latest discoveries that have provided the final proof that aspirin can prevent cancer.
Back in the 1980s, hereditary cancer was becoming more and more of a prominent feature in our clinics, and in particular people who had a condition called familial adenomatous polyposis. Now, I'm not going to show you lots of horrible pictures, but this is just a small version, and this is the inside of the colon of a 23-year-old young man. These are all adenomatous polyps, precancerous polyps lining his gut, and he had over 1,000 of them because he had a spelling mistake in a gene called the APC gene, which is basically the key gene to control the cell division in your gut. The gut divides very quickly, and the APC gene regulates that. And if you have an inherited faulty copy of that, then every cell in your gut is working with only one version of the gene, because you get two of everything. And therefore, it's very likely, as you go through life, you'll make a mistake and lose the second copy, and that cell has now lost control and starts to grow like bilio and produces these adenomatous polyps. And one of those would have turned to cancer, because we know statistically that people with this condition all get colon cancer by the time they're about 40 or 45. And so what we do is we bring them in, if we can catch them, and we tell them about this, and we do endoscopy, and then we offer them colectomy. They have their colon removed and the small bowel connected to the rectum, or in fact now an artificial rectum is produced instead. So you can treat it surgically, but it seemed to us that it would be nice if we could do something medical. And we went to visit a family down at Monk Wearmouth. And when we walked in, I was struck by a young boy called Jonathan. And Jonathan had little bumps on his forehead. Now, one of the sort of other effects of this genetic condition, in addition to these polyps in the gut, is you get these little bumps on your head. So as soon as I saw Jonathan, I knew he carried the gene, even though he hadn't got the polyps yet. And it got us to talking and thinking, wouldn't it be nice if we could actually put him on something to stop him getting polyps? And it got us to thinking a bit more that, in fact, here was a condition where we could test treatments for cancer, because these kids were getting these polyps so fast that if we could suppress their polyps, then it would be relevant to the rest of us. We could test things in them we couldn't test in the general population. And that gave birth to this idea of genetically targeted trials. Highly motivated people with the same medical condition, identical genetic condition, homogeneous and otherwise, already under surveillance, already being followed by the hospital, so fairly cheap to keep in touch with. And because so many of them got problems, we didn't need so many of them. So this is a way of presenting that. The little lines are the confidence intervals, the 95% confidence intervals. Do we believe this or not? And the line vertically there is 1. So essentially, if your treatment or your observation does not make any difference, you should sit on that line. Anything that makes it less likely to happen takes you to the left. Anything that makes it more likely to happen takes you to the right. The only one of all these studies, these are all observational studies though, these are not trials, these are simply looking at people who were taking aspirin. And all of them, with the exception of this one by Paganini Hill, showed a shift to the left. If you average all this out, it looked like around about 60% level. In other words, about a 40 to 50% reduction in cancer in the people taking the aspirin. So people were very impressed by this, but they said, yeah, but this could just be an observational bias. For example, it might be that if you take aspirin, you're more likely to bleed. If you're more likely to bleed, you go to the hospital, they check you out, they find you cancer, and they treat it or whatever. So there's ways of explaining it other than saying it's down to the direct effect of aspirin. Nevertheless, we were sufficiently convinced aspirin might work to set up the trial, and so we set up this factorial trial, exactly as we'd done with the vitamins, whereby you either got starch and aspirin, or just starch, or neither. And we were giving people a fairly big dose of aspirin by modern standards, 2 standard tablets. And there are people in the audience who took part in our second study, I'll come to in a moment, and we had to discuss with them the fact that this could give them ulcers, it could have side effects. On the other hand, we had pretty good evidence that one or other of these treatments, or perhaps both, would reduce the cancer risk. And so we pressed ahead and we gave 2 different types of starch in our 2 studies. Now, I'm not going to tell you much about CAP1 except to say that it was actually a real challenge to persuade teenagers to take diet supplements for fairly obvious reasons. They also belong to another species. Actually this was quite a hard job, but we did get some results from that. We had 200 kids, young people under 18 who were familial polyposis carriers, and we managed to drag it out eventually and get a result. And what we found was that the people who were taking the placebo had, on average, there were more big polyps, or the biggest polyp they had was bigger than in the group who were taking the aspirin. But the overall polyp count, we couldn't say for sure was less, partly because there were so many of them. It's very hard to say if you cut the incidence of polyps from 1,000 to 800, you know, it still looks like an awful lot of polyps. And we videoed and we counted, we did all sorts of stuff, but we couldn't convince ourselves that we'd made a big difference. Nevertheless, we were already on another track. We also took little biopsies of the wall of the bowel, and these are called crypts in the gut. And that's the surface of the bowel there. And these are the growing areas where the cells that line the gut are produced. Down at the bottom here, there are about 6 stem cells in each of these crypts, pushing new cells up to the top to produce a defensive lining on your gut. And without that, we die. That's what we replace that lining every 4 days. And those crypt stem cells are pushing up cells all the time to reline the gut. And the crypts, we were able to count them, and Julie, our technician, diligently counted and measured these and showed that, in fact, the people on the starch got shorter crypts, which suggests it was sort of damping down cell division in the gut. Probably a good thing, but not enough to say that it was preventing cancer. So what we then did was we actually looked at the people who had also been in the study who weren't on aspirin, because there was a small group who just took starch because they were sensitive to aspirin, and that boosted the numbers a bit more. We also had a group of people who got more than one cancer at a time, and of those, 6 of them developed multiple cancers, and 5 of those were not getting cancer. So in other words, if you count cancers rather than people, the difference becomes more obvious. And finally, if you actually go back to the data and look at the people who were taking aspirin for at least 2 years, as opposed to having been randomized to aspirin but having dropped out or whatever, then in fact the figure becomes 0.03. So there's a 97% probability that that difference is real. And if you just take the bottom line, because what people really want to know is, am I going to get cancer or not? And what we found was that the people who had been on the aspirin in those first 2 to 4 years had significantly less cancer overall. And that difference had a significant value of 0.03. So that was, and what was even more exciting was that when we looked at the people who'd been on treatment for 24 months or more, then the p-value became 0.01, 99% sure that that's right. So in other words, although these are what are called secondary analyses, all the weight of the evidence is confirming that this worked. How then is the aspirin working? Well, the aspirin is going to have a very early effect, because the time course from developing a polyp to developing a cancer in Lynch syndrome is about 4 or 5 years. And yet we are seeing here an effect that's lasting at least 5 years after people stop taking the aspirin. So it's got to be an effect on the precancerous stage, even probably before the polyps form. So the question that we posed back in 1998, which we now think is even stronger, is that maybe we've lost something from our natural diet. When we were back in the Stone Age, gathering food as we wandered around in the mountains, we would be picking up plants that had been infected. We would get lots and lots of salicylate in our natural diet. But our natural diet now contains no salicylate. All our plants are grown in greenhouses. They grow in fields which are carefully treated with herbicides and all sorts of other sides. So they never see an infection, and they don't make salicylate. And I'm sorry to say, we did check, organic food doesn't have much salicylate in it either, because people don't eat the bad-looking ones, they only eat the good ones. So our theory is that maybe salicylate got lost from our natural diet, and we kind of expected to have a bit of it there. And what salicylate might be doing in the body is exactly the same as it does in plants. It might be inducing faulty cells to fall on their sword. Cells in those crypts that I told you about earlier that might have spelling mistakes in them that might later cause cancer are persuaded to die. So in summary, aspirin at 600 milligrams reduces cancer burden in Lynch syndrome by about half. The effect takes about 3 years to kick in. Treatment for an average of 29 months has an effect for several years. We didn't see an effect in adenomas, so we think it might be having an effect on stem cells. And finally, we're now thinking about doing CAP 3. It took us ages to think of the name. And CAP 3 will be a dose-finding study. So we're going to ask people who are at high risk of colon cancer to take different amounts of aspirin. And that's going to take us a few more years, but it will answer the ultimate question of whether a low dose of aspirin is as effective as a high dose, which would obviously have fewer side effects. And with that, I think I'm finished. Thank you for your attention.